Let's take a look at the malware classification. So classifying the malware actually depends on three teams. Security operations team, which is working in the SOC. We have the incident response team, and we have the malware researcher, which is working on the origin and authorship to understand its genealogy and the purpose. The malware which are of the same family can have a similar code, capabilities, purposes, origins, even the authorship and the function names. Now, differences in the same family can originate from different compilers used to compile the source code, for example, sections of the code added and or removed to modify the functionality of the malware itself. So, in a nutshell, malware samples that evolve over time in response to changing detection or mitigation strategies often also exhibit similarities between the older and the newer versions. Now, malware classification also includes the classification of non-malicious binaries. So, determine whether a piece of software is malicious, traditionally by signature matching. However, we can have a metamorphic or polymorphic viruses and worms. So employ static and dynamic obfuscation technique to change the characteristic of the code, the behavior, and the properties. There where the data science can help us understand the behavior and also tell us that whether a malware belong to the same family or not. Now, let's take a look at how data science and machine learning can help us the problem which are caused by the modern malware. The first is the fuzzy matching. So, for example, we can have an exact match of a file which is malicious with another file, but with the help of the fuzzy matching, we can have the similarity between two or more entities using a distance metric. So matching engine that previously emitted a binary output match or no match. And it depends on the confidence score as well. So this approximate matches actually point us closer to one another are considered to be very high similar or considered to be highly dissimilar. This is the advantage of the data science and machine learning. The second thing is the automated property selection. So we can have the property selection algorithms in the machine learning to have an automated property selection which is done by the data science. We can also have the dimensionality reduction and feature selection algorithm can even uncover the latent properties of the samples. The third thing is the adaptiveness. The malware evolves over time as its authors add functionality and fix bugs. So the changing behavior of the malware to avoid the detection. Now, the classification system of a machine learning is adaptive enough that has consistently tracked and detected gradual changes in the samples. This is one of the main advantage of machine learning and data science to be used for malware analysis. So contributions of the machine learning are that we try to understand the attacker's objective and the origin can help us defenders to devise more far-sighted mitigation strategies. We also try to find patterns and similarities in the data in the fold of machine learning algorithms. However, one thing which we have to consider is that some aspects of this task still require human effort. So generating descriptive data sets in a format that aids algorithm in the learning and classification task is a job that requires a data scientist. So data scientist is not just a person who has the knowledge of the machine learning algorithm, but in this case, the understanding of the both how malware works and how algorithm works is needed. So a mixture of security and data scientist, which is the main objective and contribution of this course. Thank you.